Hello. Nice. Hello, everybody. My name is Dragan Rakita. I am one of the code developers that are building Reth. It is modular, contributor-friendly, and basically fast implementation of the Ethereum protocol. Execution layer, basically. What I want to talk about is basically these four things. A little bit of the history, while the new client is important thing. What are we missing currently in the present state? We focus a little bit on the modules, basically what Reth is composed of, while they're important for us, while that modularity is important for the new clients. I'll give a little bit of developer insights to just show what basically path that we took, what decisions that we made, and I think talk about a little bit of the current state of the client. Recent history. Let's start from the present. Diversity in Ethereum ecosystem is very important. In essence, it allows you more security. It decentralizes network. It allows basically, if there is some potential problem in the one client, other client should take over and just move the network forward. But the present state is the GET is the majority client that everybody uses. So if the GET has some of the potential consensus bug or something like that, it will break the network will stop, and other client would just report the problem. They don't have any way to move Ethereum forward. Other things that other clients bring is innovation. It's a little bit experimentation. It provides users and developers new way to use Ethereum. A little bit history, 2022 is the year that I started working on Ethereum. In this time, we had GET as even more major Ethereum client, and the second biggest one was Parity Ethereum. Parity Ethereum that time basically moved away from Ethereum space and just open sourced their client and rename it to Open Ethereum. 2021, it's a brilliant hard fork. Here we see fork of the GET named TurboGet. There is Nethermine and Besu. Parity renamed to Open Ethereum. London hard fork. Around that time, Open Ethereum was deprecated. It was basically the client that was not well maintained, and it basically time got over it. And at that time, we decided to deprecate it, to not implement merge, basically Paris hard fork. We see Aragon that was renamed for the TurboGet fork of the GET, and see Besu and Nethermine taking traction. Paris was the important one. 2022, people started noticing and basically focusing more on diversity. And as it was one of the major points of the merge, as the merge was one-way thing, because when you switch consensus, you cannot go back. In that sense, diversity was a little bit more focused. And present, Nethermine, Aragon, and Besu are the major clients. GET is still the major client. Now we come to the last year, September 2022. Paradigm started building their own client. It's built in the Rust. It uses some ideas from the Aragon. Idea is to have like very modular, very well-made, documented client that we hope to will improve the ecosystem and development experience. It's built to Rust. Basically, modularity is one of the major points of us, because we want to be able, if needed, to just rewrite components if they don't perform well enough, or to be able for community users, anybody, just use components, add their modification and use it with the rest of the system. Clean abstraction, standalone Rust libraries basically allow that hackability of the code and allow for client to be used in different ways. We want to be flexible and in configuration to support both the archive node and the full node. We're currently supporting on the archive node, but we will add full node support. And most important, it's MIT Apache license, so anybody can use it. It's like open. I'll focus a little bit on components, what's inside the client. Database footprint, I wrote here, database is most important aspect of any Ethereum client because how you write to database, how you read to database matters a lot in terms of how fast you are syncing, how fast you're doing things. And the database layout is the most impactful thing in the Ethereum client. For the plain state, we are using Dragan flat key value database. Our archive node is under 2 terabytes. We are very pleased with that. We'll probably shrink in the future a little bit. There is some idea that we want to implement. We are still work in progress, and currently we are very satisfied it's under 2 terabytes. Optimization of the data, basically optimization of the memory footprint is very important as any byte matter. For example, 2 billion transactions give you, if you save hash of transaction, it's additional 50 gigabytes, 64. And still optimization depends on how you read and write data. First module that can be important is provider. Because every Ethereum node, and Reth including, has simple key value database, fetching data in proper order is very hard. You need to know the layout of the database, you need to know encoding that's used, you need to know basically where the data is. Provider is the one library that's going to wrap that. It will give you high-level abstraction on the low-level database access. Basically, it will allow you to fetch one block where the block is split into multiple tables. It will just one library call. Other than that, it will allow you to have access to the history state without worrying how the state is indexed. One good thing is that we can have multiple readers, and basically you can run your client, and client will push data, write data to the database, and you can have another process that's going to just read. And that allows new flexibility. Initial sync with the pipeline with NVMe SSD hard disk is under 2 days. Pipeline is basically used for initial sync. It's optimized to handle that multi-block execution and multi-block preparation of the execution and localization after that. It's one of the that is pioneered by Aragon. We have in our database, we are just saving the canonical chain that allows you a little bit flexibility where we know that the data and blocks that are inside the main in the database are the canonicalized block, and we just reorg if needed. Pipeline is optimized for the ranges. Side penny block, we have different module that handles that. Pipeline, for example, stages that are inside the pipeline are the header body that are specialized for the fetching of the blocks, headers, basically data that's needed from outside from the P2P network. There is some sender recovery, total difficulty that are needed as preparation for the execution. Execution that executes, creates receipts, everything around that. And there is a few stages that do localization and history indexing. And after that, there is transaction ID. There is some places that we want to improve. One of the things that we could introduce as ETL is to read and write data a little bit differently, but either way, we are very fast even without it. Longest time for execution is, of course, execution. Interface is one of the core libraries. It's basically a list of traits that abstract away components. Basically, we implement the trait, specify the trait, and somebody is going to implement it. That allows you very abstract away modularity between the libraries. So you can just implement your own trait and just be sure that you comply with the rest of the system. P2P downloader module. P2P is one of the things that does discovery, management of nodes, timeouts, and sending, receiving requests from the P2P network. It's one of the things that every client abstracted in some way because it's very easy to abstract. It allows you to handle peer management in one place and don't think about it. Downloader is wrapper around P2P. It's glue between the rest of the system and P2P module that allows you to download headers, blocks, and full header blocks and bodies, whatever you need. In the future, maybe we switch downloader to not fetch P2P, but idea is to fetch from some server or something like that. That could be very interesting. Blockchain tree. It is memory structure that stores validate blocks that are received from the consensus layer. It is it's needed as a separate entity that allows us to have multi-site blocks that can potentially be received, and it does reorganization on our canonical chain that's the database. Market tree is, of course, calculated to check everything. Why this is possible, why it was not possible with proof of work is for proof of stake, as we have consensus, we have finality. Finality allows us to have a limited amount of blocks that we can reorg. In the practice, that's just one block, but in the theory, it can be 64, 2 epochs. Engine is the thing that drives the Reth. Basic engine is the starting point of the Reth. Engine is the one that handles engine API, that is consensus layer blocks that we receive, and fork choice update that we receive. It switches between history sync that is in the pipeline and the live sync that is in the tree. It's basic synchronization point of the node, and it basically requests, if needed, it payload building, basically creating new block. Other module, transaction pool, is expected. It's very complex thing, but most of the devs just expect to work as it needs to be DDoS protected. It needs to have ordering of the transactions by base fee, priority fee. It needs to have buffer for the nonce gaps. Everything around that sounds simple, but it was not. RAM is the EVM basically that I built 2 years ago. It is tested. It passes all the Ethereum tests. It is used in the Foundry. This is an APC, basically standard APC that you expect everywhere. And we have metrics and Prometheus. That's very rough component flow. This looks something like this. Engine is at the top. It drives tree, pipeline, and building. Pipelines basically takes blocks from the downloader and fetches from P2P, while the blockchain tree and pipeline touches provider to send write data or reorg if needed. Development insights. Even with EVM already done, it was very hard to figure out how to do it. We had few ideas that was not, when we started implementing it, when we started basically doing it, we figured out that are not good enough and we needed to switch our path. There are a few dead ends that we approached and basically reverted back. We initially started with the pipeline and just wanted to be pipeline to be the main component that does everything. Very soon we figured out that we overburdening one component of our system and we needed to build multiple ones. We wanted to basically use pipeline for the finalization and the using and integrating pending side blocks, everything around it, but figure out the tree and separate components are basically better option. We wanted to pipeline for to be the main entry of the Reth. Basically, the pipeline starts everything and figure out what needs to be done. But we move that logic inside the engine. So the engine drives everything. Pipeline is there for the initial sync. It's optimized only for one thing. Even that was very hard to do, that initial sync and everything around that. We tried to use all the build Merkle implementation, but there was a problem having optimized way to Merkleize full state and one point of time. We had a lot of memory problems there, so we built our own. And the biggest insight is basically speed depends on the data. How you access data, how you write data. It matters a lot if you are writing, if you're just appending data to the table, you know the order, you know how block numbers that you receive, you just push it. There is there is even difference if you are writing randomly and if you are writing a lot of data that is pre-sorted. Even that can get you like big improvement in the speed. One of the things that we started is transaction level granularity. Granularity in sense that our Hive node could access history state on transaction level. We initially thought, hey, this is a good idea. It will slightly increase the database, but it will have better performance. But after few research and talk, basically, we already built that and saw that the database was not that small. It became a little bit bigger. And we figure out that for the history access, users mostly use providers. Everybody that uses that uses block level indexing, and they even like optimize for the multi-block logs state accesses. So we revert that, basically build block level granularity and shrink our database a little bit. Compression data was fun one. This on the main, the section was, we have our encoding that compresses a little bit of data, but is encoding. Smart way how you basically remove zeros. But for some fields in the section receipt, we introduce standardized compression. You can look at that at PR, and it was like 200, 300 gigabytes smaller for the section, and around 200, 300 for receipts. We was very surprised that it was this much. Current status, we are seeking minute. Basically, starting with this sentence, just leaving this sentence was like a big thing. For the 7-8 months, we built that client from scratch, and we are syncing minute. Even that is enormous job, enormous success. Project feels good in sense that we figure out what module, how they're connecting. We figure out how it's going to work. There is some bugs that we need to squash, but either way, the structure of the project feels very good. It's still, it's not even alpha, to be honest. It's pre-alpha, even before that. We are going to break database a few times. We know it. We are working currently in stabilizing some things, cleaning up some code that we know that can be better. Either way, it syncs. It is working with consensus layer, everything around that. But so you know, database is going to break. In broad strokes, we are there. We want to consolidate that libraries that I talked about, to add a little bit more documentation, just to make it a little bit easier for the guys that just want to use some components, just to use it. And that's a very powerful thing that we can do. We are open for the feedback, contribution. I think people don't notice, but working on open source project, I worked from Open Ethereum. in 2020 to now. Feedback is important. That's how the community is built. That's how you figure out your next path. You figure out what's important for the people that use your software. You can figure out what's the next step for the project. So it's very important. Other than that, bug reporting and just reporting problems, it's one of the major things how you stabilize the software. We are around 100 contributors. Community is very important. Basically the guys that built the Foundry, and Foundry became something special in Ethereum ecosystem, are now building Reth, and you can expect same thing that you can find in Foundry to find the Reth. So the same community feedback, same community outreach, and everything around it. The team already knows how to build it. I think that's it. Thank you for listening. Questions?
Hi, so for the initial state sync, is it like Dragan where it downloads the state via BitTorrent?
Not exactly. Okay. We are still figuring out how to do that snap syncing state downloading around that. Our first intention was like, let's archive sync from the beginning to the end. After that, we will figure out what's our next step. We want to consolidate what we are currently having and then talk about, is it going to be BitTorrent? Is it possible to do it like SnapSync that does that Get and Nethermind does it? Maybe there is some different ways we can do it, but either way, it's now open question. But this is something that we are probably going in some way to implement in the future.
Okay, thank you.
We hear questions here.
Yeah, so I quite like that Reth was doing transaction level state. For replayers, it makes life a lot easier. Is it irrevocable now that you're moving to block level state?
Yeah, we removed that part. Basically, it was harder to support both of them, and we figure out you can still execute all the section in the block to get to the state of the transaction, but for the history access, the main important thing is like the block level. You are basically iterating over logs of multiple blocks. You're iterating over the blocks of multiple section, but either way, there will be ability to have like, give me traces of that transaction. It will be a little bit longer because you need to execute past transaction. But either way, we have fast EVM, we have the state. You can expect performance as the Foundry has it. Basically, Foundry does it in the same way. Yeah. Question there. All right. Or left, depending on.
Is it working? Yeah.
Yep.
Yeah. Thanks for the talk. You said you wrote the code from scratch, but didn't you reuse a lot of code from Sputnik VM and Akula?
Not exactly. EVM I built 2 years ago. This is not new component. There was drama related. That's one-man drama that unfortunately it happened. But at that point of time, we had like 20% of the code. It was, I'm not sure basically, but it seems Twitter just come to the train and just, I'm not sure what happened. Aragon basically deprecated a lot of things at that point of time. They removed Polygon, they removed Binance, and they deprecated their client. And I'm not sure, but it seems that the main developer just wanted to introduce drama.
So there's no code?
Sorry?
there is some code, or?
We use MDBX, wrap around it, and I think we use LP. That's very small part of the code. We are not forking Akula. That basically, that's how the Aragon Turbo gets started. We built it from scratch, and it was like, what else to say?
Yeah, thank you.
One quick question about the, I also talked with the Laserminds teams and their developers, and they told me that why gas is so popular because more like EF, Ethereum Foundation is more likely to support them. So will this case also be a situation for your project? Will EF, they provide limited help for Nethermind, but for this one, are they interested or they will also provide limited help? Yeah.
Basically, this undertaking is mostly driven by paradigm. I'm not sure about future. Maybe that basically we are talking with Ethereum Foundation. The guys from Ethereum Foundation are testing the client as a lot of providers. We're in contact with them. Basically, I was the guy that was on Open Ethereum. A paradigm is known in the space, and they're basically building open source client. And it's you cannot be more open source than MIT and Apache.
Cool.
I think that's it. Thank you very much.